Apache Spark. This word can generate a spark in every Hadoop engineer's mind. It is a big data processing framework which is lightning fast in cluster computing, and the core reason behind its outstanding performance is the resilient distributed dataset, or in short, the RDD. Hello everyone, I'm Ravi from Edureka, and today I'll focus on the topic called RDD using Spark. Before we get started, let's have a quick look on the agenda for today's session. We shall start with understanding the need for RDDs, where we'll learn the reasons behind which the RDDs were required. Then, we shall learn what are RDDs, where we'll understand what exactly an RDD is and how do they work. Later, I'll walk you through the fascinating features of RDDs, such as in-memory computation, partitioning, persistence, fault tolerance, and many more. Once I finish the theory part, I'll get your hands on RDDs, where we'll practically create and perform all possible operations on RDDs. And finally, I'll wind up this session with an interesting Pokemon use case which will help you understand RDDs in a much better way. Let's get started. Spark is one of the top mandatory skills required by each and every big data developer. It is used in multiple applications which need real-time processing, such as Google's recommendation engine, credit card fraud detection, and many more. To understand this in depth, we shall consider Amazon's recommendation engine. Assume that you are searching for a mobile phone in Amazon and you have certain specifications of your choice. Then, the Amazon search engine understands your requirements and provides you the products which match the specifications of your choice. All this is made possible because of the most powerful tool existing in big data environment, which is none other than Apache Spark. And resilient distributed dataset is considered to be the heart of Apache Spark. So with this, let's begin our first question. Why do we need RDDs? Well, the current world is expanding the technology, and artificial intelligence is the face for this evolution. The machine learning algorithms and the data needed to train these computers are huge. The logic behind all these algorithms are very complicated and mostly run in a distributed and iterative computation method. The machine learning algorithms could not use the older MapReduce programs because the traditional MapReduce programs needed a stable state HDFS. And we know that HDFS generates redundancy during intermediate computations, which resulted in a major latency in data processing. And in HDFS, gathering data from multiple processing units at a single instance was time consuming. Along with this, the major issue was the HDFS did not have random read and write ability. So using these older MapReduce programs for machine learning problems would be impractical. Then the Spark was introduced. Compared to MapReduce, Spark is an advanced big data processing framework. Resilient distributed dataset, which is a fundamental and most crucial data structure of Spark, was the one which made it all possible. RDDs are effortless to create, and the mind-blowing property which solved the problem was its in-memory data processing capability. RDD is not a distributed file system. Instead, it is a distributed collection of memory where the data needed is always stored and kept available in RAM. And because of this property, the elevation it gave to the memory accessing speed was unbelievable. The RDDs are fault tolerant, and this property brought it a dignity of a whole new level. So, our next question would be, what are RDDs? The resilient distributed datasets, or the RDDs, are the primary underlying data structures of Spark. They are highly fault tolerant and they store data amongst multiple computers in a network. The data is written into multiple executable nodes so that in case of a calamity, if any executing node fails, then within a fraction of a second, it gets back up from the next executable node with the same processing speeds of the current node. The fault tolerant property enables them to roll back their data to the original state by applying simple transformations onto the lost part in the lineage. RDDs do not need anything called hard disk or any other secondary storage. All that they need is the main memory, which is RAM. Now that we have understood the need for RDDs and what exactly an RDD is, so let us see the different sources from which the data can be ingested into an RDD. The data can be loaded from any source, like HDFS, HBase, Hive, SQL, you name it, they got it. Hence, the collected data is dropped into an RDD. And guess what? The RDDs are free-spirited. They can process any type of data. They won't care if the data is structured, unstructured, or semi-structured. Now, let me walk you through the features of RDDs which give it an edge over the other alternatives. In-memory computation. The idea of in-memory computation brought the groundbreaking progress in cluster computing. It increased the processing speed when compared with the HDFS. Moving on to lazy evaluations, the phrase lazy explains it all. Spark logs all the transformations you apply onto it and will not throw any output onto the display until an action is provoked. Next is fault tolerance. RDDs are absolutely fault tolerant. Any lost partition of an RDD can be rolled back by applying simple transformations onto the lost part in the lineage. Speaking about immutability, the data once dropped into an RDD is immutable because the access provided by RDD is just read-only. The only way to access or modify it is by applying a transformation onto an RDD which is prior to the present one. Discussing about partitioning, the important reason for Spark's parallel processing is its partitioning. By default, Spark determines the number of parts into which your data is divided, but you can override this and decide the number of blocks you want to split your data. Let's see what persistence is. Spark's RDDs are totally reusable. The users can apply certain number of transformations onto an RDD and preserve the final RDD for future use. This avoids all the hectic process of applying all the transformations from scratch. And now, last but not the least, coarse-grained operations. The operations performed on RDDs using transformations like map, filter, flat map, etc. change the RDDs and update them. Hence, every operation applied onto an RDD is coarse-grained. These were the features of RDDs, and moving on to the next stage, we shall understand the creation of RDDs. RDDs can be created using three methods. The first method is using parallelized collections. Next method is by using external storage like HDFS, HBase, Hive, and many more. The third one is using an existing RDD which is prior to the present one. Now, let us see, understand, and create an RDD through each method. Now, Spark can be run on virtual machines like Spark VM, or you can install a Linux operating system like Ubuntu and run it standalone. But we here at Edureka use the best-in-class cloud lab, which comprises of all the frameworks you need at a single-stop cloud framework. No need of any hectic procedures of downloading any file or setting up environment variables and looking for a hardware specification, etc. All you need is a login ID and password to the all-in-one ready-to-use cloud lab where you can run and save all your programs. Let us fire up our Spark shell using the command spark2-shell. Now our Spark shell has been fired up. Let's create our new RDD. So here we are creating our new RDD with the first method, which is using the parallelized collections. Here we are creating a new RDD by the name parallelized collections RDD. We are starting a Spark context and we are parallelizing an array into the RDD, which consists of the data of the days of a week, which is Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Now let's create this. Our new RDD parallelized collections RDD is successfully created. Now let's display the data which is present in our RDD. So this was the data which is present in our RDD. Now let's create a new RDD using our second method. The second method of creating an RDD was using an external storage such as HDFS, Hive, SQL, and many more. Here I'm creating a new RDD by the name Spark file, where I'll be loading a text document into the RDD from an external storage which is HDFS, and this is the location where my text file is located. So the new RDD Spark file is successfully created. Now let's display the data which is present in our Spark file RDD. So the data which was present in our Spark file RDD is a collection of alphabets starting from A to Z. Now let's create a new RDD using the third method, which is using an existing RDD which is prior to the present one. In the third method, I'm creating a new RDD by the name words, and I'm creating a Spark context and parallelizing a statement into the RDD words, which is Spark is a very powerful language. So this is a collection of words which I have passed into the new RDD words. Now let us apply a transformation onto the RDD and create a new RDD through that. So here I'm applying map transformation onto the previous RDD, that is words, and I'm storing the data into the new RDD which is word pairs. So here we are applying map transformation in order to display the first letter of each and every word which is stored in the RDD words. Now let's continue. The transformation has been applied successfully. Now let's display the contents which are present in our new RDD, which is word pair. So as explained, we have displayed the starting letter of each and every word, as S is the starting letter of Spark, I is the starting letter of ease, and so on. L is the starting letter of language. Now we have understood the creation of RDDs. Let us move on to the next stage, where we'll understand the operations that are performed on RDDs. Transformations and actions are the two major operations that are performed on RDDs. Let us understand what are transformations. We apply transformations in order to access, filter, and modify the data which is present in an RDD. Now, transformations are further divided into two types: narrow transformations and wide transformations. Now, let us understand what are narrow transformations. We apply narrow transformations onto a single partition of parent RDD because the data required to process the RDD is available on a single partition of parent RDD. The examples for narrow transformation are map, filter, flat map, partition, and map partitions. Let us move on to the next type of transformations, which is wide transformations. We apply wide transformations onto the multiple partitions of parent RDD because the data required to process an RDD is available on multiple partitions of the parent RDD. The examples for wide transformations are reduce by and union. Now, let us move on to the next part, which is actions. Actions, on the other hand, are considered to be the next part of operations which are used to display the final result. The examples for actions are collect, count, take, and first. Till now, we have discussed about the theory part on RDD. Let us start executing the operations that are performed on RDDs. In our practical part, we'll be dealing with an example of IPL matches data. So here, I have a CSV file which has the IPL match records, and this CSV file is stored in my HDFS, and I'm loading my matches.csv file into the new RDD, which is CK file, as a text file. So the matches.csv file has been successfully loaded as a text file into the new RDD, which is CK file. Now let us display the data which is present in our CK file using an action command. So collect is the action command which I'm using in order to display the data which is present in my CK file RDD. So here we have in total 636 rows of data which consist of IPL match records from the year 2008 to 2017. Now let us see the schema of our CSV file. I'm using the action command first in order to display the schema of our matches.csv file. So this command will display the starting line of the CSV file we have. So the schema of our CSV file is the ID of the match, season, city where the IPL match was conducted, date of the match, team 1, team 2, and so on. Now let's perform the further operations on our CSV file. Now moving on to the further operations, I am about to split the second column of my CSV file, which consists the information regarding the states which conducted the IPL matches. So I'm using this operation in order to display the states where the matches were conducted. So the transformation has been successfully applied and the data has been stored into the new RDD, which is states. Now let's display the data which is stored in our states RDD using the collection action command. So these were the states where the matches were being conducted. Now let's find out the city which conducted the maximum number of IPL matches. Here I'm creating a new RDD again, which is states count, and I'm using map transformation and I'm counting each and every city and the number of matches conducted in that particular city. The transformation is successfully applied and the data has been stored into the scount RDD. Now let us create a new RDD by name state count m and apply reduce by key transformation and map transformation together, and consider tuple 1 as the city name and tuple 2 as the number of matches which were considered in that particular city, and apply sort by key transformation to find out the city which conducted maximum number of IPL matches. The transformations are successfully applied and the data is being stored into the state count m RDD. Now let's display the data which is present in state count m RDD. Here I'm using take action command in order to take the top 10 results which are stored in state count m RDD. So according to the results, we have Mumbai, which conducted the maximum number of IPL matches, which is 85, since the year 2008 to the year 2017. Now let us create a new RDD by name FIL RDD and use flat map in order to filter out the match data which were conducted in the city Hyderabad and store the same data into the file RDD. So the transformation has been successfully applied. Now let us display the data which is present in our FIL RDD, which consists of the matches which were conducted excluding the city Hyderabad. So this is the data which is present in our FIL RDD, which excludes the matches which were played in the city Hyderabad. Now let us create another RDD by name FIL and store the data of the matches which were conducted in the year 2017. We shall use filter transformation for this operation. The transformation has been applied successfully and the data has been stored into the FIL RDD. Now let us display the data which is present there. We shall use collect action command. And now we have the data of all the matches which were played, especially in the year 2017. Similarly, we can find out the matches which were played in the year 2016 and we can save the same data into the new RDD which is FIL2. Similarly, we can find out the data of the matches which were conducted in the year 2016 and we can store the same data into our new RDD which is FIL2. I have used filter transformation in order to filter out the data of the matches which were conducted in the year 2016 and I have saved the data into the new RDD which is FIL2. Now let us understand the union transformation. We shall apply the union transformation onto the FIL RDD and FIL2 RDD in order to combine both the data present in both the RDDs. Here I am creating a new RDD by the name union RDD and I'm applying union transformation on the two RDDs that we created before. The first one is FIL RDD, which consists of the data of the matches played in the year 2017, and the second one is FIL2, which consists the data of the matches which were played in the year 2016. Here I'll be clubbing both the RDDs together and I'll be saving the data into the new RDD which is union RDD. Now let us display the data which is present in our new RDD which is union RDD. I'm using collect action command in order to display the data. So here we have the data of the matches which were played in the years 2016 and 2017. And now let's continue with our operations and find out the player with maximum number of man of the match awards. For this operation, I'm applying map transformation and splitting out the column number 13, which consists of the data of the players who won the man of the match awards for that particular match. So the transformation has been successfully applied and the column number 13 has been successfully split and the data has been stored into the man of the match RDD. Now we are creating a new RDD by the name man of the match count. We are applying map transformations onto our previous RDD and we are counting the number of awards won by each and every particular player. Now we shall create a new RDD by the name man of the match and we are applying reduce by key transformation onto the previous RDD which is man of the match count, and again we are applying map transformation and considering tuple 1 as the name of the player and tuple 2 as the number of matches he played and won the man of the match awards. Let us use take action command in order to print the data which is stored in our new RDD which is man of the match. So according to the result, we have AB de Villiers who won the maximum number of man of the matches which is 15. So these were the few operations that were performed on RDDs. Now let us move on to our Pokemon use case so that we can understand RDDs in a much better way. So the steps to be performed in Pokemon use case are loading the Pokemon data.csv file from an external storage into an RDD, removing the schema from the Pokemon data.csv file, and finding out the total number of water type Pokemons, finding the total number of fire type Pokemons. I know it's getting interesting, so let me explain you each and every step practically. So here I'm creating a new RDD by name Pokemon Data RDD1 and I'm loading my CSV file from an external storage that is my HDFS as a text file. So the Pokemon data.csv file has been successfully loaded into our new RDD. So let us display the data which is present in our Pokemon data RDD1. I'm using collect action command for this. So here we have 721 rows of data of all the types of Pokemons we have. So now let us display the schema of the data we have. I have used the action command first in order to display the first line of our CSV file, which happens to be the schema of our CSV file. So we have index of the Pokemon, name of the Pokemon, its type, total points, HP, attack points, defense points, special attack, special defense, speed, generation, and we can also find if a particular Pokemon is legendary or not. Here I'm creating a new RDD which is no header, and I'm using filter operation in order to remove the schema of our Pokemon data.csv file. The schema of Pokemon data.csv file is been removed because the Spark considers the schema as a data to be processed. So for this reason we remove the schema. Now let's display the data which is present in our no header RDD. I'm using action command collect in order to display the data which is present in no header RDD. So this is the data which is stored in a no header RDD without the schema. So now let us find out the number of partitions into which our no header RDD is been split into. So I'm using partitions transformation in order to find out the number of partitions the data was split into. According to the result, the no header RDD is been split into 2 partitions. I'm here creating a new RDD by name water RDD, and I'm using filter transformation in order to find out water type Pokemons in our Pokemon data.csv file. I'm using action command collect in order to print the data which is present in water RDD. So these are the total number of water type Pokemons that we have in our Pokemon data.csv. Similarly, let's find out the fire type Pokemons. I'm creating a new RDD by the name Fire RDD and applying filter operation in order to find out the fire type Pokemons present in our CSV file. I'm using collect action command in order to print the data which is present in Fire RDD. So these are the fire type Pokemons which are present in our Pokemon data.csv file. Now let us count the total number of water type Pokemons which are present in our Pokemon data.csv file. I'm using count action for this. And we have 112 water type Pokemons present in our Pokemon data.csv file. Similarly, let's find out the total number of fire type Pokemons we have. I'm using count action command for the same. So we have a total 52 number of fire type Pokemons in our Pokemon data.csv file. Let's continue with our further operations where we'll find out a highest defense strength of a Pokemon. I'm creating a new RDD by the name defense list, and I'm applying map transformation and splitting out the column number 6 in order to extract the defense points of all the Pokemons present in our Pokemon data.csv file. So the data has been stored successfully into our new RDD, which is defense list. Now I'm using max action command in order to print out the maximum defense strength out of all the Pokemons. So we have 230 points as the maximum defense strength amongst all the Pokemons. So in our further operations, let's find out the Pokemons which come under the category of having highest defense strength, which is 230 points. In order to find out the name of the Pokemon with highest defense strength, I'm creating a new RDD with the name defense with Pokemon name, and I'm applying map transformation onto the previous RDD, which is no header, and I'm splitting out column number 6, which happens to be the defense strength, in order to extract the data from that particular row, which has the defense strength as 230 points. Now I'm creating a new RDD again with the name maximum defense Pokemon, and I'm applying group by K transformation in order to display the Pokemon which have the maximum defense points, that is 230 points. So according to the result, we have Steelix, Steelix Mega, Shuckle, Aggregon and Aggregon Mega as the Pokemons with highest defense strength, which is 230 points. Now we shall find out the Pokemon which is having least defense strength. So before we find out the Pokemon with least defense strength, let us find out the least defense points which are present in the defense list. So in order to find out the Pokemon with least defense strength, I have created a new RDD by name minimum defense Pokemon, and I have applied distinct and sort by transformations onto the defense list RDD in order to extract the least defense points present in the defense list. And I have used take action command in order to display the data which is present in minimum defense Pokemon RDD. So according to the results, we have 5 points as the least defense strength of a particular Pokemon. Now let us find out the name of the Pokemon which comes under the category of having 5 points as defense strength. Now let us create a new RDD which is defense Pokemon name 2 and apply map transformation and split the column number 6 and store the data into our new RDD which is defense with Pokemon name 2. The transformation has been successfully applied and the data is now stored into the new RDD which is defense with Pokemon name 2. The data has been successfully loaded now. Let us apply the further operations. Here I am creating another RDD with name minimum defense Pokemon and I'm applying group by key transformation in order to extract the data from the row which has the defense points as 5.0. The data has been successfully loaded now, and let us display the data which is present in minimum defense Pokemon RDD. Now, according to the results, we have two number of Pokemons which come under the category of having 5 points as their defense strength. The Pokemons Chassiny and Happiny are the two Pokemons which are having the least defense strength. So with this, we come to an end of this session. I hope you understood what exactly RDDs are and what are its features and how useful it is in data environment. So if you have any queries regarding this session, please feel free to mention it in the comment section below. Till then, thank you and happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!